Hello everyone. I welcome you on behalf of Matoshi College of Engineering and Research Center for this online lecture of Basic Electronics. Myself, Mr. V.R. Vadekar. Today I am going to take this lecture and discussing the few points about our basic electronics. Now, first, that what is electronics? Now, the electronics basically it is a field of science and engineering that dealing with electronic devices and utilization of these devices. And this word basically electronics it came from the two words electrons and mechanics. Now, nowadays as you can see there is a lot of development in the field of this technology, electronics devices. Electronic devices basically are capable of rectifications, amplifications, control generations, conversion of light into electricity and electricity into light. Now, before going towards the evolution of electronics, that today's generation all we are aware of laptop, your smartphones, how it is actually working. Nowadays lockdown it is there, all the education colleges, schools are closed, but our education it is not shut, it is not closed. Still we are going to do the online lectures, we can send the communication, we can send messages to other, we can learn from online. How it is going to possible? It is only meant due to this high development in this field of electronics. Now, before moving towards this, what is basically what are the components of electronics or next things, I want to draw your attentions towards the evolution of electronics that suppose in prior 1940, this 19 up till 1949 there is called a first generation computer, and this first generation computer it was called as ENIAC, that is electronics numerically integrated and calculators. All this ENIAC computer you can see it is going to take the space of almost two rooms, right? And it is developed in 1946. Now these ENIAC computers they use what? Vacuum tubes. Vacuum tube it is the first electronic device that is nothing but a diode, which is invented by John Fleming. Diode, why we call it as a diode? Because it has a two terminals are there over here, this one. After that it came a triode. It means two. Third one, the third terminal it came, it is inserted between this anode and this cathode, it is there. After that, tetrode it came. After that, pentode it came. Now, what is going to be happen? See, you can see on this screen that how vacuum tubes, it looks like. As I already told, it is a first generation computer. Now we will see the details of this brief of this ENIAC computer. See, this ENIAC computer, it is not a computer, it is basically electronic, calculator it is there. And it is much faster than electro or mechanical devices. See, 17,000, more than 17,000 vacuum tube, 7,200 crystals, 1,500 relays, 70,000 resistors. All these are going to make this ENIAC computer, which consumes a lot of power, that is a 150 kilowatt, right? How power consumption and how slow it was. Next, it came that is a second generation computer. Second generation computer it is from 1959 to 1964, and this second generation computer they use a transistor. And from the screen on the screen you can see that how the first transistor it looks like, which is going to be developed in 1947 by Shockley, Burdine or Brayton, at Bell Labs. And this first transistor, it was called as a point contact transistor. And nowadays, the transistor that we are going to use it, they are call it as a junction transistor. Next, it came a third generation computers that is from 1964 to 1970. These computers they use ICs, built on this wafers. The bipolar transistor, it continues to be important device in this ICs actually, right? So as like your IBM 300 or your Honeywell, your ICL, your IBM 370, it is there. It all comes under this what third generation computer. Now after this one, it came a fourth generation computer, that is from 1917 up till now. Now, in this one, they have used a technology of LSI and VLSI as well as VLSI. It means large scale integration, very large scale integration, very large scale integration. So, all these computers, it is going to be used, in government body, in education sector, in business, as like your Intel, your Apple, your IBM, it is there. So, and the next, it is called a fifth generation computer. The fifth generation computer, basically they are not going to use a non-numeric data. They are going to take a non-numeric data and they are converting into some useful things. It means they are going to put a human intelligence into your this one. And nowadays, many working it is also going on, and a few companies, they are going to use this computers also, that we call it as a computer. Now the next topic, it is what is the impact of electronics on our society and industries. As you know, as all of us, we are going to use mobile phones, laptop, PC. Due to this, there is a very fast communication in between the people regarding mishaps, regarding some floods, accidents, or you can do a banking transaction over there. You can do the online reservation tickets, it is there. As well as many apps are available over here nowadays. This lockdown period, it is going on, and you can do the you can attend the lectures. You can get the research development about on which sector it has been going to be take place. How? By means of this laptop, by means of this mobile PCs, like that one. Next, it is called televisions and radio. As you know, televisions and radio, it is for entertainment purpose as well as for knowledge purpose, right? It saves our energy, it saves our time. Next, medical electronics. Doctors and scientists continuously, they are going to put a research that how we can use the application of electrons in the field of therapy, in the diagnosis, as like your X-ray machines, your electromyography, electrocardiography, then ultrasound, as like this one. Defense system, it is there. In defense system, there is a huge development. As you know that India, it is going to purchase the Rafale from this Russia, from America. So all this, guided missiles are there, rocket launchers are there. They are going to hit the target, and they can sense it. Even a night also, they can see the particular target and hit the target. Next is on your industries, that you're numerically controlled or computerized numerically controls your robotics. Basically, in mechanical mechatronics industries, as electronics as well as mechanical, all these automation industries, they are going to replace all the human working by means of this are electronics devices or some robotics. Okay. So now the next important thing that we are going to see it now, it is a components, electronic components. So basically, electronic component, it is divided into a two major parts, that is active component and passive components. Before going to see the what is active and what are passive, please see what are the examples of this active and passive components. As you can see, this resistors, capacitors, inductors, switches, thermistor, LDRs. These are the examples of what? Passive components. And transistors, BJT, JFET, SCR, operational amplifier, MOSFET. These are the examples of what? Active devices. Now, we are going to see that what is active devices and what is passive devices. So active devices are those devices which are going to inject a power to the circuit, whereas passive devices are incapable of supplying energy. Active devices are capable of providing power gain. Passive devices are incapable of providing power gain. Active devices can control the current, the energy flow within the circuit, whereas passive devices, it can't. Active devices, it can change. We also called it as modulators or semiconductor devices, which can change the shape of our electronic waveforms. It could be current, as like its amplitude, it frequency, as like that one. So these are what all active devices, whereas external power, it is required in order to start the basic operation of your active devices, whereas no extra power, it is used for passive devices. You can see that resistor, basically it is used for what? It is used to oppose the flow of current, right? And its unit, it is in ohm, and it is denoted by capital R. Capacitor, it is there. Capacitor, it is used to store the charge as an electrostatic in the form. It is going to oppose the change in the voltage, which is what's unit is given in farad, which is denoted by capital C. Inductor, it is also there. Inductor, it is also a passive device which is used to oppose the change in the current, whose which is going to be denoted by capital L, and whose unit, it is measured in what? It is a Henry. And it is going to store the energy in the form of what? Electromagnetic energy. Now, these transistors, this operational amplifier, they can do the amplifications. They can convert rectifiers, convert, this AC into DC. So they are going to modulate it something. It could be amplitude, it could be frequency. So they are called what? Active devices. Now, the next topic that we are going to see, it is a solids, classification of solids. From many schools, from schools you are going to see that solids, basically it is divided into three parts, that is conductors, insulators, and semiconductors. As we all knew that conductors, are metals having a free electrons in its outermost orbit, hence they can easily conduct electricity by applying what? Electric field. And the examples of this conductors, it is aluminium, it is there, copper, it is there, etc. Now, the next, it is called insulators. Insulators basically are what? Bad conductor of electricity, those who couldn't constitute the current. Examples: plastic, it is there; wood, it is there; paper, it is there. Next, it is your semiconductors. Now, the most important device that we use in electronics, it is a semiconductor devices. So on this whole subject, we are going to focus on the semiconductor devices. So what is basically a semiconductor device? Semiconductor device, it is a device which is whose conductivity, it lies between what? Insulators and conductors. It means it could act as insulators as well as it could act as conductors. The most famous or best example of semiconductors are what? Silicon and germanium. Now, we are going to see or we are going to understand this conductor, insulator, and semiconductor by means of this what? Energy band diagram. So you can see this energy band diagram. This energy band diagram, it is for conductors actually. For on x-axis you can see it is the energy, sorry, x-axis it is the interatomic distance, it is there, and on y-axis energy, it is there. So if you will find it, if you will see it, there is a overlap between this valence band and conduction band. Now, what is valence band? Valence band, it is nothing but the band in which the valence electrons are there, right? And conduction band, it is there, it is a band in which the electrons which are available for the conduction, that is called a conduction band. So you can see there is overlapping of this valence band and conduction band. As you know that to form a current, the electrons needs to jump from valence band to conduction band, but there is no need to get the extra energy or possess extra energy, to jump from valence band to conduction band. There is already a overlapping, it is there, so electrons can easily move from valence band to conduction band, and hence conductors are always, they can conduct the electricity. Now, the next energy band diagram, it is for insulator. As you can see, there is a huge gap, it is there, between conduction band and valence band. So since there is a huge band, it is there, gap, it is there, and this gap, we call it as a forbidden energy gap. So valence electrons could not jump easily onto this conduction band. Why? Because this gap, it is there, and almost this gap, it is what? See, insulator, it is approximate more than 6 electron volt energy it is required. Now, what is this forbidden energy gap? Basically, the energy required to break the this gap band, and it makes the electrons to jump from valence band to conduction band. But since it is an insulator and there is a huge gap, so in insulator, it couldn't conduct the electricity easily, or it could not conduct the electricity. Next, it is what? the semiconductor. See, there is a little gap between this valence band and between this conduction band. Only 1.21 electron volt for silicon. So when electrons present in a valence shell, they don't have energy, they couldn't jump from valence band to conduction band. But as these valence electrons get the energy, that could be light energy, thermal energy, they possess the energy and they are going to jump from valence band to this conduction band. And in this manner, in semiconductor, the current, it could be flown. So hope you understood conductors, insulators, as well as semiconductors from energy band point of view. Now, we are going to see the most important thing is of a semiconductor, because whole subject electronic, it is based on semiconductor device. So we are going to focus on semiconductor device now. In periodic timetable, as you know, the semiconductor, it is comes in fourth group. Fourth group, why is it so? Because at its valence shell, the semiconductor, it has a four valence electrons, right? Conductors, it comes in group third or lower than that one, whereas insulator, it comes under a group fifth or above that one. And you can observe the conductivity is much higher in conductor, medium in semiconductor, as well as negligible in insulator. Now, we would talk about a semiconductor. Basically, semiconductor, it is of two types: intrinsic semiconductor and extrinsic semiconductor. Now, over here, the most important thing, that why this classification it is there, intrinsic and extrinsic. Intrinsic semiconductor, basically it is called as a pure semiconductor. Silicon and germanium, these are the pure semiconductor devices are there. We call it as intrinsic because there is no any impurity in this one. And what happens actually in intrinsic semiconductor, that since valence electron, they don't possess energy, so they behave as an insulator. But when they absorb the energy, they get the energy, they get excited, and they can easily jump from valence band to conduction band, and they can make the current. But whatever the resultant current which is going to be formed by this intrinsic devices, it is very very low. And hence, pure semiconductor devices or intrinsic semiconductor devices, we couldn't use for electronics applications. So to make the semiconductors devices used in electronics applications, we need to add some external impurity. What is impurity? Basically, the impurity we are going to add into the semiconductor devices in order to make it conduct, so that it can easily conduct. So that's why the process of adding an impurity to this intrinsic semiconductor or pure semiconductor, it is called a doping. See guys, this is a very important term. So whenever in examination, if this doping it is came, semiconductor types it is came, so when you are going to explain the extrinsic semiconductor, you always explain a process of doping. Now we are going to see the process of doping in detail. Again, you can see the extrinsic semiconductor, it is again divided into two parts, that is p type and n type. Now what is p type and n type? Basically, the impurity, it is of two types: trivalent impurity and pentavalent impurity. Trivalent impurity, basically it is in third group. It means it has a three valence electrons. Since it has a three valence electrons, the majority in p type semiconductor, the current it is going to flow due to the majority of holes. That's why it is called as p type. Whereas in pentavalent impurity, it means it has a five valence electrons, so it has extra electrons. Semiconductor has four electrons, pentavalent it has a five electrons. So this one extra electron, it is going to responsible for the flow of this electron, this current. Hence the majority of the current, it is going to flow in n type semiconductor, it is due to of electrons. That's why we call it as what, n type semiconductor. Now, from the figure, you can easily understand this n-type semiconductor. As you know, the pentavalent, or we can call it as a donor impurity. These are the examples: arsenic, phosphorus, antimony it is there. So suppose antimony it is there, and over here silicon it is there. Now, as you know, the silicon, it has a four electrons, and this pentavalent or donor impurity, it has a 5 electrons. So you can see they have made the 4 covalent bond. One, this two, this three, and this four. But since donor, it has a one extra electron, that is, we call it as a free electrons. So in this lattice structure, when this diffusion semiconductor it has been made, in that one a free electrons are there which is always ready to conduct. So whatever the current, it is going to flow due to the majority of this free electrons. And since this is going to donate the free electrons in order to constitute the current, that's why we call it as a donor impurity. And the whole semiconductor, we call it as what? N type semiconductor. Now, moving to P type semiconductor. P type semiconductor, as you know, this it uses a trivalent impurity. Trivalent, it means it has a three valence electrons. Now, what are the examples of it? It is a boron, it is there, indium, it is there, and gallium, it is there. Now, suppose, as you know, there are four electron wars for silicon, it is there, and in the middle there is a boron, it is there. You can see this boron, it is going to make a three covalent bond with silicon. One, two, and this three. But what about this bond? This is an incomplete one because there is one electron and there is one hole. And remember, hole, it is nothing but an absence of electron. And this hole has an affinity towards the electron, towards a negative charge. So this hole, which is a positive charge, it is always going to accept the negative charge, that is an electron. That's why we call it as a acceptor impurity. So whatever the current it is going to flow in P type semiconductor, it is all due to what? Due to the majority of holes. That's why, and majority of holes which carries a positive charge, and hence we call it as what? P type semiconductor. Now, today's this last topic of this today's lecture, it is called a currents in semiconductor. Basically, there are two types of currents in semiconductor. First is drift current. Now, as you can see, there is a conductor, it is there, and which has been applied to a some voltage, it is there. It means external field, it is there. So when this external field it has been applied, you can see in the figure, these are the electron. These electron drift towards the positive terminal of the battery under the effect of this electrical field. And this movement, the process under which these electrons are moving towards the positive terminal of the battery under this effect of electric field, this is called a drift current. The current which is going to flow this under this process, it is called what? Drift current. And the velocity with which this currents this electrons are moving, are flowing, it is given by what? It is given it is called as drift velocity. So hope so you understood this. And next is what? Diffusion current. Diffusion current in the sense what? Suppose a doping it has been there, and you can see in this slab it is there. This region it has a high concentration of electrons, whereas this region it has a lower concentration of electrons. As you know, there is always a movement from high concentration, high density region to low density region. So whatever it is there, you can see the electrons are moving from high concentration region to low concentration region until this equilibrium it has been reached. So the process by which this current it is going to flow from this high concentration region to low concentration region, this process is called diffusion process. And under this process the current it is called is what? It is diffusion current. So hope so you have understood all the topics today. So thank you very much for today's lecture, and the next topic we would see in further lecture. Thank you very much.